Okay, so I'm really happy to be talking today with Oran Wasserman and Dr. Justin Jones to discuss the recent PLOS ONE Lab Protocol paper entitled An Effective Protocol to Isolate and Mechanically Test Silk Fibers Spun from Osmia lignaria, say, fifth instar larvae, and the associated detailed protocols in protocols.io. Justin was born in Montana and raised in rural Wyoming, where his early experiences fostered a lifelong curiosity about the natural world. He earned both his bachelor's and master's in science degrees in molecular biology from the University of Wyoming, and later completed his PhD in biology at Utah State University in 2015. Justin is now an associate professor at Utah State University, where his research focuses on structural proteins and their transformation into functional biomaterials, including recombinant fibers and neuroactive matrices. His work bridges fundamental molecular biology with translational applications in medicine and defense. Justin is also the founder and chief scientific officer of Mixtech Bio, a biotechnology startup commercializing hagfish-derived protein materials for use in disease modeling and regenerative systems. Oran is a PhD candidate in molecular biology at Utah State University, where he studies fibrous proteins with a focus on Osmia lignaria, silk, and cocoon characterization, and the development of recombinant hagfish intermediate filament materials. Oran, Justin, thank you so much for being here with me today to discuss this paper and the protocols.
Thank you. Happy to be here.
Thank you for having us.
So, to kick off, can either of you explain briefly what the protocol is about, how to use it, and why it is relevant?
Yeah, absolutely. Our protocol provides a detailed method to isolate and mechanically test single silk fibers produced by the solitary bee Osmia lignaria. The protocol utilizes a 3D printed well plate rearing protocol developed by Dr. Mary Kate Williams and Dr. Diana Cox Foster at the USDA ARS Pollinating Insect Research Unit in Logan, Utah. The 3D printed rearing system allowed us to observe the development stages of the larva and allow us access to the larva for silk isolation. The protocol, you monitor the silk initiation, and then once it's identified, the silk fibers were isolated via two techniques from the larva or from elongating fiber as it's produced. Then the isolated fibers are mounted into C-cards, C-shaped C-cards, and for mechanical testing. The protocol is relevant because bee silk is understudied, and with this protocol, we are hoping to bridge the knowledge gap in this area.
And Gabriel, I'd just add that before this protocol came out, there was not a very good means by which to test bee silk. And so the innovation behind what Oran has done and the other students and faculty members on the manuscript is it's a very efficient means to extract those fibers without overly stretching them before you actually get to mechanically test. So it gets fibers in as a native state as possible for mechanical testing.
And if I recall correctly from reading your paper, another advantage is that the cocoon remains intact, right? Like you do not perturb the development of the larvae, so it can proceed actually to metamorphosis. Is that correct?
Yeah, that's correct. And in our opinion, that's one of the biggest advantages of our protocol, because then that allows the protocol to be used in larger, potentially in larger rearing assays, where a few fibers will be isolated and tested, or isolated and utilized for other methodologies, and the overall assay will continue as expected.
So, Justin, you mentioned already that at this point, when Oran and your colleagues decided to embark in this project, there wasn't any other method that would allow the extractions of these fibers with the natural properties. Can you elaborate a little bit more on what was the state of the art and why the development of this protocol is so significant for the field?
Yeah, you know, and Oren may have to correct me on some of my bee biology, but when the larvae spin a cocoon and they encapsulate themselves, the fibers are getting glued together as part of that cocooning process. So trying to extract single fibers off of that cocoon is challenging at best because they're glued together in relatively small increments. And so you just end up with very small chunks of fiber. Additionally, those cocoons have aged, right? And the larvae, you know, has put whatever material into the cocoon, effectively tainting some of those fibers. And so this method really then allows you to test fresh, unperturbed fibers and gain mechanical insights into those fibers.
What kind of experiments or applications has or will this protocol enable that weren't possible before?
Utilizing just the isolation part of the protocol, researchers can take the silk and implement some physical or structural characterization techniques such as SEM, FTIR, Raman, etc. And with the point that we discussed that all the larvae that we utilize continue to cocoon completion, some studies regarding spider silk have demonstrated there is an effect of pesticides on intesticides exposure between of the silk compared to spiders that haven't received the treatment. So we are hoping that researchers will utilize our protocol to make those connections. If researchers will look at nutritional requirements or pesticide exposure, utilizing our protocol can potentially give us that type of correlation.
So I would like us now to go a little bit more into the details and history of the protocol development itself. As you were standardizing the method, what were the highs and the lows? Was there anything that you tried but didn't work and didn't make it to the final version of the protocol?
Yeah, as Justin mentioned, the way that the bees produce the silk is glued together, and then we hypothesize it's useful for the function of the cocoon. However, in our initial attempts, we tried to isolate fibers from the formed cocoons, and it was challenging and laborious. The fibers were brittle, and many of the fibers that we isolated have broke either in the mounting stages or the testing stages. So we can consider that as the lows in the experiment, trying to figure it out, and the highs come where we decided to change focus and isolate fibers directly from the larva or shortly after silk initiation. And we managed to isolate and test many fibers within hours. And another high point was the observation that all the larvae that we utilized for the experiment continued for cocoon completion.
For the user of the protocol, what is your advice in terms of the most critical steps? Are there any parts that are particularly tricky and others might make a mistake on?
Yeah, we have identified two critical points in the experiment. First is the timing of the isolation and the development observation. there is a fairly short amount of time between silk initiation and cocoon completion. The larva spin silk at different, can start spinning silk at different areas in the well plate. So it's critical to observe the larva and identify when silk initiation happens. If the isolation will occur later on, that might require cutting into the silk mesh or altering the already existing structure that can potentially hinder the natural cocoon completion. So that's the first critical point. And as Justin mentioned earlier, the fiber handling. From our experience with other protein-based fibers and information in the literature, stretching the fibers, for example, can change the structural, the mechanical properties of the silk, and that will give us a non-representative data regarding the naturally occurring silk produced by Osmia lignaria or other solitary bees. So with the fiber handling, you want to make sure that both in the isolation and in the mounting stages, the fiber has slack and it's not being stretched.
And I would like to hear your thoughts about how easily do you think this protocol can be used either directly or with modification on other understudied bee species? And you probably haven't done it, I don't know, but if you think that optimization will be required, what are your thoughts on that? Like, what would you guess people will have to change to make this protocol work in other bee species?
While we haven't tried to implement this protocol to other solitary bee species, we suspect that the majority of the modifications will be based on the specific development and natural habitat that the bee grows in, which will reflect, for example, in the 3D printed well plate diameter or in the rearing temperature. And we assume that those modifications will require some tuning, but we think it's manageable. Yeah.
I would like us now to change gears a little bit and discuss your motivations to send the protocol or the collection of protocols actually to PLOS ONE to be peer reviewed as a standalone methodological paper.
First, because there is minimal information regarding solitary bee silk. We wanted to get the information out there. We try to provide as many details as we can. And the overall goal is to increase this research area and to provide reliable methodologies.
And how did the feedback that you received from the peer reviewers shape the final version of the protocol?
Overall, the feedback was very useful. It helped us identify areas in the protocol that needed extra clarification or additional data points or any additional information that will help researchers to replicate our methods. And overall, it was a great, it helped us improve the overall quality of the paper.
And why did you decide to make the peer review history public together with your paper?
We want to increase the transparency behind our research. We believe, or we are hoping, that researchers looking at our protocol and will also view the peer review process can get additional information or look at the rationale behind the points that was brought up, and that will overall increase the transparency and applicability of the protocol.
Gabriel,
And
I'd like to just add too that, I think it's important for young scientists, particularly that may be reading this, that perhaps have not gone through the peer review process, to have some evidence of just exactly what they can expect. And methods papers are, they're relatively easy reads, and so the review process is relatively easy to understand. for these young scientists. So I think it's important from a learning perspective as well to have that process published and out there.
Absolutely. Thank you. And my last question might be a little bit speculative at this point because the paper is relatively young. It was just published at the end of February. But what do you think has been or will be the significance of publishing this methodological paper for both of your career, considering the different stages at which you two guys are?
Yeah, I'll start, Oran, and then maybe you can jump in. Even though it's a relatively young paper, it's already had almost 460 downloads. So it's gaining some traction and some interest, which I thought was great. But as far as the significance goes, particularly for Oran as a graduate student, he came up with the project. He sought funding for the project and secured that funding and followed it through, all the methodology development to this methods paper and other manuscripts that are going to come out. So that's a real growth experience for a graduate student to have. And I think when it comes to going out there and looking for jobs or employment beyond or even postdocs, that's going to be a pretty big feather in his cap to say that, I came up with this idea and I followed all the way through the publication. That's a big step. And for me personally, my laboratory, aside from the rewarding aspect of watching Oran's growth as a graduate student, my laboratory is a biomaterials laboratory, and we tend to focus on silks. So we want to broaden our scope as far as we can and look at a bunch of different protein-based biomaterials, particularly the fibers-based ones, just so we can begin to build that database a little bit about what's out there and how we might be able to use them.
Oren, anything to add to this question?
I think Justin answered very well. I don't have too much to add. I think once the paper was published, we got some conversations started with some researchers with diverse backgrounds, and that's always exciting to see how interdisciplinary research can affect a variety of different fields.
Thank you so much. I don't have any other question at this point. I don't know if there's anything that we haven't touched that you would like to discuss.
I don't have anything, Gabriel.
I also don't have anything.
Well, thank you so much.
Thank you.
Thank you very much.